Good afternoon, everybody. We're back with another analysis video discussing Tropical Cyclone Dikeledi again. It's now entered the Mozambique Channel and we'll be moving closer to Mozambique tomorrow, and we'll be moving south in the next coming days once it moves away from Mozambique, with the potential for pretty noticeable intensification, like I mentioned in the last video, but there are some changes in the forecast and the kind of environment that I want to discuss, including some other things which I will bring into the discussion later in the video. So, thank you all for coming to watch. Let's get started with the forecast then, and the kind of situation that we're in. Currently, what the official Météo France forecast currently has, they've estimated it as a severe tropical storm with an intensity of 50 knots with 10-minute winds, converted on a standard basis to the American 1-minute standard. It's 55 knots. And it's forecast to keep its severe tropical storm category status for next 12 hours at least, before intensifying further as it nears closer to Mozambique. We're going to look more into the kind of environmental pattern which is going to allow for potential intensification in the coming days, and the current situation which will contribute to how and the kind of possibilities and how a Dikeledi could evolve, because there are multiple possibilities. There is still some disagreement between the guidance, I'll get into that, and definitely a varying kind of peak intensity potential. So this is the forecast, kind of what we have. They still forecast an intense tropical cyclone peak, generally kind of a long peak in the central southern Mozambique Channel, before it moves south of Madagascar and begins to enter the kind of subtropics mid-latitude region. So, first of all, what I wanted to discuss is kind of the track evolution. But before we get into that, I want to discuss the current situation, current structure, how the cyclone is doing at the moment. So, brief kind of analysis of what's happened in the past 24 hours. We can see it made landfall. It did make landfall eventually over the northern tip of Madagascar, and its structure did kind of become a little bit more deformed, as noticed here. That central dense overcast doesn't really become as evident anymore. It's turned more into a shear pattern. You can see the convection kind of display struggling to really organize in a way. You can see it's kind of one-sided on the low-level circulation before it does eventually try to wrap and kind of developing that curved band structure, as you can see there. And what's pretty clear is that, let's look onto, actually I forgot to do something. For Dikeledi here, looking at the latest microwave images that have came, you can see that that's kind of that kind of deformed structure. There is a kind of curved band, sheared structure that's prevalent here. If you look at some of the older images that we have, we'll be able to see that, yeah, there's an evident curved band pattern there. Here a bit more noticeable with the higher resolution MSR2 imagery. So we're not at that core structure stage yet, like we were yesterday before landfall. We're not at that stage at the moment anymore, really. And obviously, as I've discussed yesterday, this is mainly attributed to the kind of harsh terrain, which, although trek over land was fairly short when it did make landfall, what should be noted is that the terrain is harsh, it's tall, there are mountainous lands here, and after it passed, although convective activity was initially good due to good orographic lift, that ended up not becoming such a good thing later, because obviously the flow coming in from the other side of the mountains initiated downsloping effects, which meant dry air, and I guess overall just a dry mass, really dry air mass coming in from the mountains up here, got taken into the low-level circulation, and alongside with the shear to take in it did begin to struggle. So that's why we had some weakening happening over the past few hours, and generally over the past day really, since landfall. What should be noted here is that cyclones typically passing over this area of Madagascar and generally over the west, even the east, can sometimes happen. If you get close to mountains and you do stay along those mountains fairly long, your flow that goes through the mountains and comes back out may not be so beneficial. That's something to watch out for, really, with cyclones coming into this region. Now, as it moves into the channel, obviously 10:27, so that was a few hours ago. It's recently passed over the devastated island of Mayotte, which got affected very badly after Tropical Cyclone Chido made its way over last month. Still recovering, and obviously the passing of Dikeledi hasn't made it much better now. That convective mass on the microwave imagery here, evidently seen that it did cover the island pretty largely. There are reports of flooding happening on many villages, many areas. So pretty bad situation there. I'm yet to take a look at the damages that have happened at the northern tip of Madagascar. I'll look into that later. But yeah, so impacts happening to Mayotte as obviously it's passing, and though if we look at the latest animated infrared satellite imagery, we can see here that it has kind of attempted to develop. Obviously, I think I did look at this again. That kind of developing curved band structure, really trying to organise now, despite some sheer prevalent. We can also see a pretty noticeable channel there, poled outflow channel, with expansive cirrus there going over. Sorry, not poled, equator wood outflow channel. That's moving that way to the north. So that's helping it. So it is trying to develop, it is trying to redevelop after its trek over Madagascar, and it's suffering of downsloping effects. And that's kind of the situation that we're in right now. Let's take a look at the reasoning behind the intensity. If we look into the official analysis and forecast document that's been published by Météo France, they've got the Rorschach analysis of 3.5, which is the equivalent to a standard 55 knots on the 1 minute standard. But obviously, considering that the 10-minute average is used by Météo France, 50 knots, again, seems very appropriate. Also seems quite appropriate considering the general estimates that we have. It might be on the lower end, but there's a very, as evident here, very large range of kind of what the estimate could be. Very large discrepancy. We've got estimates ranging from 45 knots up to around 65 for this time. So, you know, taking middle bound like the Joint Typhoon Warning Centre has, which they went 55 for 12 o'clock Zulu. They took the middle bound. I haven't looked into their reasoning yet. I don't think they have actually published the reasoning for this advisory time. But they went 55 knots for the time. And Météo France took the lower bound, closer to the lower bound of 50. But they, again, taking a 10-minute average standard, then obviously they are going to be biased a little bit low, which is perfectly fine. It is equivalent to 55 anyway. Enough of that talk though. Big discrepancy, so it's not the easiest to kind of analyse the intensity. One thing that may or may not be helpful is a advanced scatterometer pass did come early today, and that was. It's debatable whether it should be taken at face value. Honestly, at this point, probably not. It's a small, compact circulation. The values that we got were 37.2 knots. With a 25 kilometer resolution standard at this kind of structure and at this point really. It's not appropriate to take it at face value. Usually undersampling can be taken to 40, maybe 45 knots at this kind of position, which would be kind of appropriate if considering an unofficial kind of my own patentee estimate using the Dvorak technique. If we look at the structure again, typically probably what I would say is probably it's around a 3.03, a patentee of 3, which would be equivalent to a 45 knots. If taken that as the FT, the final T number, but again, big discrepancy between a lot of the objective intensity estimate guidance really, and it's not easy to estimate. But what should be noted actually is that if using, let's actually go back to the microwave images that we had. Let's take a look at the low-level structure. There was an evident low-level core structure that was present not long ago. I'll have to look at the archive. I think it was this one. Yeah, so as we can see, a low-level, very evident core structure here. Despite the very sheared convective mass, what ended up happening underneath, kind of near the low-level circulation on the low levels, is there is an evident core structure there, which may suggest that the intensity may or may not be a little bit higher than what the appearance would suggest. We've seen this with many storms happening before around the world historically, so it should be noted that the advanced scatterometer values, the outputs, we may need to take them with a grain of salt and try to evaluate them differently. So, enough of the current intensity and evaluation of the current structure and the current position of the system. As we can see, it's evidently moving west-southwest as was expected yesterday. It's moving towards Mozambique now. Looking at some of the guidance, we will take a look now, kind of what the ensemble, oh, I don't know what's happening here. At the various ensembles, I want to take a look at what's kind of happening with them. I don't think we have, I don't think this is working. Not an issue though. That's fine. I have an alternative. So again, let's take a look at the kind of ensembles that we have here and the various possibilities from each model. We've got the American ensemble and the European. We look closely. This west-southwest movement will continue, and it will be a sharp turn south. So we continue to have that consensus on the kind of track pattern that will happen. What the main concern really is the kind of time that it will make that turn south and how drastic it will be. What our first focus will be mainly is what happens near Mozambique. Will it go inland Mozambique briefly? We discussed this yesterday, but it's very important we analyse this now. More so very important as some of the kind of guidance that we have has actually trended with the recent kind of developments that we've had over the past couple of hours and its movement. We've had a trend closer towards the coast of Mozambique, and if it does indeed go overland, we very well may have a problem in terms of intensity and then the kind of intensity prospects that the system may have. So it's very difficult, first of all, to estimate in the long term. There's a lot of variation between the guidance. We can see the American's actually kind of weaker compared to the European, which is actually unusual. It's usually the other way around. We need to look very closely at the evolution near Mozambique, because if it does go inland, the intensity prospect will be less favourable, I should say. It will be less ambitious compared to what we've seen and what we're seeing here with the European. It is all dependent on how long it stays over water. If it goes into Mozambique, its current developing structure will get ruined once more, which it will have to repair and try again. the environment will be favourable, but the more it can make out of the favourable environment, the higher the intensity prospects it will have, because it will have more time to intensify and it won't be disrupted. That's kind of what the European ensemble is showing, with many members unambiguously suggesting very significant intensification to a very likely intense tropical cyclone peak. The American, a lot more variation simply because of how close. It's leaning closer to Mozambique, but not all of the guidance is, not all of the guidance actually does take it inland. The deterministic does, and some of the ensemble members do, but not all. That's why there's so much variation. There is actually a few intensifying members that do actually intensify significantly, but some do not, because of obviously what I've just said. They go into Mozambique. But the general track is actually, there's a lot more confidence now in the fact that it will pass close to the southern part of Madagascar later down the line, and the same kind of evolution, same kind of pattern, as I've said. Very similar, sharp turn south, gradual curve east, as it gets picked up by a trough which is approaching. I'll talk more into the steering influences in a bit. So that's kind of what we have right now in terms of the guidance. I want to look more into the trends, so if we go into tropical tidbits, so obviously maybe these plots won't be working. I'm just trying to figure out if the others will. Do the deterministics work? Okay, they do work. That's fine. And we got the new 12Z run loading in as well, so that'd be nice. We'll be looking into the trends now. So obviously we do see that, yes, we do have the ensemble guidances, obviously with their current tracks for the latest runs, but I want to observe the trends that we have and see what kind of directions the models are shifting in exactly. Because through time, forecasts will change depending on short-term evolution. So let's look at the European. We got a 6Z run. We'll look at the last 4 or 5 runs and take a look at what the situations are with track. So here are all our ensemble members, and we'll see how the evolution is through time, through each run. This is where it's at closest passing to Mozambique. This is at hour 36, or it will be at hour 30, based on beginning at 12Z. It'll be sooner now, considering that we're past 12Z, we're past 12 o'clock Zulu. But yeah, generally, this is the kind of time that we have closest passing to Mozambique at the initialization of this run. Let's kind of get a trend going. Or I should probably, I'll just be able to look at this. Previous run, let's take a look at the previous run. We can see a gradual shift towards Mozambique. Well, generally what happened through time is that obviously there's big spread because uncertainty does increase through larger lead time. Big spread, general agreement on a Mozambique Channel track. That certainty does increase, based around the midpoint between Madagascar and Mozambique, but more certainty gradually shifts closer to Mozambique and leads towards that, really. But the bulk of the guidance, bulk of the members stay off the coast. Some take it inland, very minimal few do, but the bulk chunk really keep it offshore. With good prospects for intensification, as land interaction becomes less of a concern. There's a really good possibility that while we may not have a landfall, if following the European solution, we may still have a kind of situation where it passes close to land and there is still going to be a kind of disruption, because just simply the core will be moving onshore despite the center staying offshore, so we may still have some disruption. It might explain why we have kind of a bit of a stall in the rate of intensification there. The tropical cyclone intensity is kept until it intensifies further off the coast of as it moves away from Mozambique. Um, so this is the European, and we've seen trend west. Let's see how kind of this has evolved with the American. I'm not exactly sure if we can. Yeah, I'm not sure why they're not here. Um, I might be able to take a look at the trend on weather nodes. Archive images. Oh, they're all oh, right. I think the overall trend has been west for most models, though. Even if I can't show that to you lot, I I think that is the kind of situation that we have. Now, when I look closer into the deterministics, I do want to show the kind of trough ridge pattern that we have steering. So obviously we know that the cyclone's heading west-southwest. Why does the European take it further south more quickly and takes it away from Mozambique compared to the American solutions? Well, that's what I want to observe now. Looking at the deterministic evolution, we can see that yes, it takes this way, and then the influence from the first trough becomes more noticeable only at around hour 30 or 24, I think. That's when the ridge starts to weaken and it moves there. What I'm gonna look at the low level steering flow. This may just have to do with strength, really. It's not the low level steering flow that's influencing it, otherwise it would probably be going more so direct south already. Or it may be going... I'm not exactly sure, actually. It may be going a bit more due westwards if it was low level steering flow, but what we kind of have here is that strength of the system and the vertical extent is less significant and therefore does not have that pulling effect by the trough. It's not as significant compared to the European solution, which actually does intensify it more quickly sooner. Actually, is it like more sooner as it gets closer to Mozambique on a continued west-southwest path, and therefore, you know, it does get taken that way. It's actually very close to the coast of Mozambique on the deterministic run this time around, actually. I feel like this would definitely cause some disruption of some sort, but it wouldn't be as significant as a full-on landfall as some of the American guidance shows. So, I want to compare the kind of the anomaly. Yeah, very weaker like noticeably weaker on the American, really. It's a more westward track, steered further by the ridge, because the trough cannot get its grip on the system. The system's not strong enough, really. Now, my personal view on this would be that, well, first of all, let's take a look at the environment, right? The current structure seems sufficient to say it's attempting to strengthen. Let's also look at the current kind of track, because it's moving west-southwest, it's evolving, it's trying to evolve, but it may already be too late. Now we've still got quite a bit of distance to Mozambique, it could make a bit of a more shift south, but there's a bit of an issue, right? It's still at latitude just further north to 14 south. it's got a pretty long distance to make to actually be able to pass Mozambique. It might want to make a continued shift south to make sure that it can kind of get to around here where it dodges and then it makes its trek south. By the time it makes its trek south, it could already be inland. Just judging by the current motion, the time it begins to make that trek south, it may just plunge into Mozambique. I said it most likely wouldn't like go deep into continental Africa. It won't, but what the current situation is, there's an increasing possibility it will probably go into Mozambique. There's no true confidence in that, but there's increasing confidence in it. We've also noticed that through the kind of trend in the Materia France forecast cone, it's shifted closer to Mozambique. There's a real possibility that it may go and land Mozambique briefly. What does that mean for intensification prospects? Well, okay, let's take a look at the pressures that come with the European and GFS solutions. We can see here it does attempt to strengthen on the European, really intense strengthening, like literally imminently, based on this forecast. It continues its treks west-southwest, takes a bit of a shift south. It doesn't really, I mean, it gets close, but it doesn't really make a full-on landfall, and then it makes its way south. There's a 949 millibar, I think, peak, its deepest pressure, I think. Has a second peak later on. Because that structure, well, overall, what appears to be here is that it does weaken slightly for one frame, briefly. That's 980, as it passes close to Mozambique. But this doesn't seem very regular. What happens afterwards? That's its closest point, and then it like drops 12 millibars, like right as it's right offshore, which I'm not exactly too convinced that this is very realistic. There would probably be some brief weakening here, but the core structure wouldn't be absolutely, it wouldn't be absolutely destroyed. So it would definitely be able to make benefit, would definitely be able to make the most out of the very favourable environment, which it has now. Let's take a look at the upper level pattern here. Very nice equator wood outflow there. It continues kind of, especially when it's close to land. This kind of decreases under, though it is under a very broad, nice upper level anticyclone, and it begins to benefit more out of the polar outflow channel, which develops as it moves to an upper trough. The overall deep layer trough that gets picked by, that benefits off. There's a better view here when it takes a look at, let's take a bit of a better look here at the overall deep layer structure. Really good, strong upper level divergent flow moving into this trough, while it's under the influence of a pretty anticyclonic regime here in the upper levels. See the kind of barbs, this upper level ridge that's embedded within. And then it moves, eventually weakens as it kind of attempts to go within this trough, but it doesn't actually catch up with it very well. I've noticed that this would be the case, and it may just catch up, accelerate eastwards within the westerlies, but may not actually make extratropical transition, or it may do it very late. I want to compare this with GFS solution like I said I would. It moves overland. Let's take a look at the 6E for a better full view. It moves overland, core structure wrecked, that vorticity weakens very evidently. But the regime, very favourable again, upper level anticyclonic flow, you can see this here. And picked up by this trough, because eventually it will have to be, it's a very strong trough. Big influence there. And it does try and make the most. It does strengthen, it tries to rebuild because the environment is favourable. Upper divergence, still favourable poleward. But then it weakens obviously as it encounters the westerlies. As it fails to catch up with the trough, unfortunately, fails to do so. Extratropical transition, it essentially fails The vorticity just weakens due to the hostile environment in the subtropics, and that's the kind of path that we have here. As we look at closer to the American solution, and we've kind of been trending towards it, the solution that happens here may be more likely. I won't rule out a very high intensity peak yet, but we must understand that the possibilities of a weaker system closer to the GFS solution is very legitimate. Now, what's going to lead to the kind of short-term intensity fluctuation? Let's take a look closer at soundings. Let's take a look at the American soundings here that we have, GFS. This pattern is not exactly the most favourable. It may or may not be enough for some reorganisation. It might be borderline, but a lot of the guidance does suggest some strengthening happening, despite this very marginal environment. While the hurricane models don't perform well, let's take a look, compare them, see what the results are. There is a significant attempt at re-strengthening from the HWRF, but it does plunge in. This kind of track, and this kind of evolution, does suggest that while attempts to re-strengthen might be there, and the pattern, the kind of environmental pattern, while it might be there for some re-strengthening, its latitude already in the kind of evolution that we have already may not be enough to take it far south enough for it to dodge Mozambique. It may plunge into it either way. We've also noticed that with the European trending closer to Mozambique and almost making landfall, despite the intensification prospects which happened right before it. So that's kind of what we have. There's not too much of an issue with dry air. Obviously there is now, but this will repair. We're currently seeing the core structure being repaired. It is going to be better in the short term at least as it tries to repair. While it moves over land, evidently another view here of the core structure struggling, but it does attempt to redevelop in the favourable environment. Now what's interesting again with the HWRF solution, let's take a look at the parent view. While it does make landfall in Mozambique, the favourable environment, I think, should be noted as something that could still lead to a high intensity peak, regardless of the landfall. Obviously we see the HWRF solution really pick up an intensification there, organisation first initially, but it does end up still intensifying quickly later down the line. This is a very favourable environment. You see the upper level anticyclone shifting further south alongside the storm as they're coupled. Big upper divergent boost into the upper trough. So once it organises, it does still have time to benefit the environment. For a shorter peak that's still at high intensity, that's also possible. But if we look at the GFS solution and what it kind of has, why does it not weaken? Why does it not strengthen much? Why does it fail to organise? Well, that's what we're going to take a look at it. The environment is not as favourable as one may look at on the HWRF, and on its way to Mozambique as well. The HWRF solution doesn't appear too realistic once looking at the soundings. So this is the most favourable environment, and this may have it struggle to develop initially, which is what's needed for it to take the most benefit out of the upper divergent environment as it interacts with the jet and interacts with the trough that's passing by. There's a lot of scenarios that could play out, and there's a lot of uncertainty. Now, obviously, if we go here, um, one thing I want to note is that regardless of the evolution that happens here, it will be a very exciting thing to note that regardless of the evolution, regardless of how stuff really evolves post Mozambique, if you can see that small island there, that will have observations for us to record. So there's general agreement for a passing near there, strong or weak, from both the American and European models, really, both ensemble and deterministic. They pass near that island, so we may get some nice observations. Yeah, that's the kind of pattern that we have here. So overall summary, we've trended closer to Mozambique, for good reason, as short-term evolution now suggests we're more likely to get closer to Mozambique. We may not escape Mozambique. There's a higher chance of a lower intensity ceiling now, but as noted by some model solutions, if it does organise quick enough within the favourable environment post-Mozambique in the channel, in the central part of the channel, it may still be able to attempt at a higher intensity ceiling. But that all depends on how it evolves. It would be most preferable for a higher intensity for it to stay offshore, even if it means even if it means having half of your core onshore. The European solution suggests that a strong intensity could still be seen even if it gets close to Mozambique. But that all depends if we have a quick short-term shift south before Mozambique, so it narrowly dodges it. And that all depends on the near-term strengthening, which it may be trying at. But we'll have to see, constantly monitor in real time, see how it evolves, see how it strengthens, see if a microwave core structure ends up improving, to see if the trough will be able to pick it up quickly before Mozambique weakens it significantly. I thank you all for watching. Thank you for watching on this update. This is my second update now. Hope you guys enjoyed. Hope you guys found this informative. Hope you guys found it working. I'm always open for advice, recommendations, opinions. Put them down in the comments. Apart from that, I'll see you all coming for watching the next update. I said I'd have some information on tropical cyclone activity in the South Pacific. Instead, that will probably be activity in the Australian region, near Australia. There is some stuff happening there. I'll have updates on that in due course. That's it from me. I'll be back with more analysis videos later. And yeah, that's it. Thank you.